Safety on the drill. Why do we need safety on the drill? Well, there's more to it than just drilling holes. Which type of drill? Cordless, electric, or simply a hammer drill? Are you drilling into masonry, steel, or just wood? These are all things we'll talk about in addition to the types of drills, where to use them, how to stand. All these things are things you need to factor in when you're using a drill. Let's move into the types of drills. In the drill family, there's about 6 different types. The staple is the corded electric drill. Been around for a while, 50 to 100 years. It's most economical. Next type is a cordless drill. In today's market, they'll range from 9 volt to 18 volt. Keyless chucks, a lot of durability. A lot of times you don't need the 110 volts with an electric drill. You just need to be able to drill a simple hole. People think the electric drill was the first one invented, though. Technically, cordless drills were. Although this one's not battery operated, it's truly cordless. For accuracy purposes, the drill press is the drill of choice. The head comes down perfectly straight and square to the work. There's also a depth gauge that you can set if you need to only drill halfway through, such as cup hinges, adjustable shelf holes. In the homeowner field, you've got a cordless screwdriver. They generally range from 4 to 9 volts, very inexpensive. Throw in the kitchen drawer or the toolbox for inserting and removing screws. A relatively new one in the last 10 or 15 years is the impact driver. It takes the technology of the air impact tools that are used on semi-trucks, tractors, NASCAR, and puts them into a portable power. This is great for putting in bolts, screws with a lot of power and yet a lot of speed. The next type is the hammer drill. A bigger brother of the hammer drill is a rotary hammer. Both of these are used in construction. They're designed to drill through masonry, concrete walls, steel, heavy timbers. In addition to the drills, you know what kind of bit to use. The most common type is a twist bit. What you think of when somebody says, go get me a drill bit. You have screwdriver bits. These can also be socket adapters, straight blades, stars, squares, or a multitude of different bit types, but they're all screwdriver bits. The problem with the twist bit, though, is you're limited in diameter by the size of your chuck on your drill. Because with a twist bit, the larger the bit gets, so does the shank. So the maximum diameter is the maximum that can go in this chuck here. So there's 3 different types of bits that can get us a larger hole. The most economical is what they call a spade bit or a paddle bit. It generates a quick, fast, large cut. Generally these go anywhere from about a 1/2 inch to 2 inches, but they produce a rougher cut. The reason they produce a rougher cut is they only have 2 teeth. The key to a cleaner cut is more teeth on a bit or a blade. So we'll move up to the hole saw. This one's typically used in construction more often. It's got a lot of teeth around the rim, and the outside rim is interchangeable with the center pilot bit. The downside to this type of bit is it's designed to drill all the way through. In woodworking, that's not always the case. So we'll move on to what's called a Forstner bit. Some people call it a Forstner bit, either one. It has a lot of teeth, produces a cleaner cut. Now to get a cleaner cut, you got to slow your feed rate down a little bit, so keep that in mind. It's got 2 chisels across the bottom and a nice small narrow starter point. This produces a flat bottom hole, for example, cup hinges, counter bores, adjustable shelf pegs. These are your most expensive, but they're worth it for woodworking. There's a couple other bits in the twist family. Back to the construction side is an auger bit. It's got a screw starter point, which allows it to grab into the wood. These are electrical contractors and plumbers love these because they get through faster than a spade bit will. And it has large flutes to let the sawdust get out of the way quickly. On the woodworking side, this one's called a brad point bit. Looks just like a twist bit, but it's got a starter point to keep it from walking. I've been mentioning a couple parts of the drill bits: starter point, shank, cutting flutes. Every bit has 3 parts. They all have a starting point, they all have cutting flutes, and they all have some sort of shaft that the chuck needs to grab a hold of. Now, how does the drill hold on to the bit? Well, there's 3 different methods. They're called chucks. The most traditional is what they call a keyed chuck. Requires a wrench. Most commonly, it's found attached to the end of the cord, so you don't lose it in the toolbox. You would disconnect your power, always when you're changing the bits. Hand adjust the chuck by adjusting the collar. Hand tighten it. Then take the wrench, and it's recommended to tighten all 3 tightening points to get an even grip on the drill bit. The disadvantage is it requires a wrench that you could lose. The big advantage, though, is the strength of the grip that it produces. That's why you're going to find these. If you look here, you're going to find them on the drill press. The newest type is a keyless chuck. The advantage is tool-free, quick bit changes. Again, there's 2 rings on this one. Loosen it so the bit slides in there, hand tighten it, and you're good to go. No wrenches to lose, which is the big advantage. However, I don't have the grip that I would get with a keyed chuck. On an impact driver, there's what they call a locking collar. Depending on the manufacturer, you're going to push or you're going to pull on this ring. And what it does is it opens up a ring and grabs a hold of this locking collar. And if you don't have the locking collar on this type of bit, it'll slip out while you're trying to use it. So make sure you have the correct type. Been talking about inserting the bits. How far do I use to insert the bit? All these chucks are different sizes. They have different depths. The shaft on the drill bit is also different lengths, different depths. The most common rule is you want to put it in as far as it will go if possible. However, on the smaller bits, the jaws of the chuck can grab a hold of the cutting flutes and potentially damage the cutter or lose your grip on the bit. So put it in as far as it can go or until the end of the shaft. And give it a good twist tight. Let's move on to the portable drills in this segment. There's some parts I want you to be familiar with. Now, whether you're using the electric version or corded version versus the cordless, they have a lot of these parts in common. They're both going to have a chuck. We've already discussed, but you got a keyed versus keyless chuck, depending on the manufacturer. You're going to have some sort of handle. You got your motor area, and the thing you need to pay attention to with the motor area is they have vents, and each manufacturer is going to have the vents in a different place. Don't cover those up with your hand when you're holding the drill, because you'll actually cause it to overheat. Trigger. Some drills are equipped with trigger locks, so make sure before you plug a drill in, if it's an electric with a cord, that you check to make sure the trigger lock's not engaged. Forward and reverse switch, going to be in different places, depending on the manufacturer. Right there on this particular electric model, above instead of in front on this cordless model. Speed selector. This drill doesn't have a speed selector because it's what they call a variable speed drill. The harder I pull the trigger, the faster it spins. Now this one has a very slow setting and either slow or fast. The slow speed's designed to have high torque for inserting screws, and the high speed setting is for just simply drilling holes. Another feature that this one has that the corded doesn't is a clutch. The clutch registers how much torque is required. For example, it takes more power to put the head of the screw into the board than it does the shaft. So once it engages to a certain point, the clutch and the head hits the surface, the clutch will engage and causing the chuck to stop. That way you don't bury it too deep, busting through or splitting or stripping your wood. The last thing, the cordless drill doesn't have it because of the type of chuck, but on a key chuck, you're going to need some sort of chuck key. And a good place to keep it is attached to the cord. This forces you to unplug it, which is a good safety policy, but it also keeps you from losing it, getting damaged. Now, when it comes to power tools, you need to read the owner's manual, be aware of all the safety operations, follow all lab safety procedures that go along with your tool. Knowing how to use your tool safely is going to prevent any accidents from occurring. And there's no more important safety rule than to wear these, your safety glasses. Okay, let's set up to drill a couple of holes here. I want to make sure my work is secured. I want to check my bit type. I'm simply drilling a 5/16 or 3/8 hole here. So I've got it installed correctly. It's centered. It's to the proper depth. The jaws aren't grabbing the cutting flutes. If this was the quarter drill, I'd check to make sure the trigger lock's not engaged. Now I'm going to position it in place. And I'm going to use two hands. The one hand obviously is for operating the trigger and the handle, but the other hand's for stability. Keeps it at the proper angle. Okay? The drill is right or left-handed. It's not, it's universal. All right, let's drill. Something's not right. The hole's got some burning in it, the bit's hot, obviously I've got some smoking. What could be the causes? Well, if I forgot to check or the drill's in reverse, that's one reason. Another one is, say you just throw your drill bits into the toolbox. They get damaged, they get chipped, they get dull. You've had it around for 10 years. It's Grandpa's bit, so it could be dull. On the drill press, use larger bits. Sometimes you could be pulling the lever too slow, causing it to overheat and burn the work. If you noticed, before I pulled that trigger, I had it touching the work. Okay, this is the only tool in the workshop that you're going to be, the tool being touching the work before the trigger or switch is engaged. So let's go ahead and drill the second hole. If you notice, when I clamp this, I clamp the scrap piece of work below. That's to protect the workbench. How I'm positioning again, two hands, but you notice my elbows. They're against my body. Just in case I hit a knot or something hard and the drill would lock up, I've got some stability. Now, I'm not standing flat-footed, feet together. You can't really see it, but my feet are off-centered, a little bit spread apart. So body position is important. Let's drill this hole. Forgot to change my clutch setting. Okay, everything went pretty smooth. Let's drill another hole. Okay. Say I didn't want to go all the way through. I could apply a piece of masking tape. It's not a guaranteed accurate way to control the depth of cut, but at least it gives you a guide, like if you're drilling a cup hinge or adjustable shelf pegs. Now, I mentioned that the scrap piece was below for protecting the workbench. It also serves another purpose. If you notice, the holes that are above the scrap piece have a clean, smooth bottom. The holes where I didn't have a scrap piece below have chip out. This is simply because you're putting pressure on the board and you're removing material. The material doesn't have the resistance that it had when it was thick to prevent breaking or splitting. So by adding that scrap piece below, it allows the resistance the board needs. A couple other notes on the drills, or portable drills. These are engaged with a brake. That's a feature you need to look at if you're purchasing a drill. It's hard to insert a screw if the screw doesn't, or the drill doesn't stop as soon as you let go of the trigger. Most quarter drills don't have brakes and they'll spin to a stop. They're designed really for drilling holes only. Variable speed versus 2-speed. We've talked about that one a little bit, but again, the faster I pull or harder I pull the trigger, the faster the drill goes. Where this one has a speed selector. And another quick review is the clutch setting. The amount of clutch setting is a variable It's not really a definite number. Some manufacturers will have 12, some will have 20, 24. It's all just how many different settings it has. But the lower the number, the more resistance it has and the quicker the clutch will engage. All right, let's move on to the impact. The impacts are simply designed for inserting and removing screws. Again, my work's clamped. If I'm screwing a board to another one, I'm going to have them clamped together for security purposes, so to speak. All right, now here's where the safety rules are going to change a little bit. You notice my hand's not in position. I need to get the drill bit started, or the screw started. If I pull the trigger just a little bit, it slowly moves. Okay, these are designed to do that. So I'm going to hold the screw up by the head where there's no thread, so I don't hurt myself, and get the screw to engage. Once it engages, I'm going to reposition my hands. Now you heard that clicking sound. That's actually the impact working to give you a little bit of extra power. It's often confused with stripping, which is something we need to address also. You need to keep the bit in line with the fastener. A lot of times you'll hit a hard spot in the wood, and the screw will start off at an angle, and the operator simply forgets to change the angle of the drill or the bit, and you end up not being at a proper angle. I'm exaggerating here, but you can see how this would strip the bit. So keep it. If the screw moves, adjust the head of the drill with it. All right, let's go ahead and insert the screw. Okay, everything went as planned. Now, say you get a split near the end. You have to put a screw in the end of the board, and you get a split. How can I prevent that? It's a simple technique called a pilot hole, which is simply taking a bit that's just slightly smaller than the shaft of the screw, so it allows the threads to engage, and go ahead and drilling through. Now let's put a screw in there and see how much smoother and easier this one goes. A lot quicker, but also no splitting. Let's review. Let's move on to the drill press. The big advantage to the drill press is accuracy. We can set up a fence for repetitive procedures like drilling hinge locations, adjustable shelf pin holes. Another advantage to accuracy is the bit is always square to the table or whatever angle I set the table to be. So let's talk about some of the parts on the drill. Let's start off by the motor covers on top. You got your gears on the inside. Drills either work one of two ways. They either have a variable speed dial up front, or they work kind of like a 10-speed bicycle with different gear configurations. You have your switch. One of the things, if you're purchasing a drill, you need to pay attention to is what they call the throat, or the quill. This one has a 4-inch throat, which allows it to drill through a block 4 inches thick. A benchtop bottle will have less of a throat, therefore only allowing you to drill through smaller blocks. Bigger drill presses, bigger throats. You have a chuck, just like on the portable drills. You have a table. Here, the way you make the drill come down is what they call a feed lever. And I can actually control with some accuracy how far down I come into the piece. This is called the depth gauge. On an older style drill, it may be a threaded rod with a bolt on there. You have in the back, you have a table lock. Unlock that, and you have the height adjustment handle. So you can set it to the proper height. When you're always done, make sure you lock it back up. And the drill press is supported by a column which supports the head and the motor. So let's set up for doing a drilling a hole. First thing I want to do is make sure I've got the correct bit installed. We're drilling a 1/2-inch hole this time. It's centered in the chuck. I'm going to check my speed setting. And most of the time in our workshop, it's going to be set for woodworking. If you have one at home and you change the metal, the speed would vary. Most of the time on your cover, there's a gauge or a chart on how to set it up for which RPMs. Setting the table height. How do we do that? Simply position your work and scrap. It's really important that on the drill press that you have a scrap piece because you got a metal table to work with. So I'm going to unlock it. Raise or lower to the appropriate height. I want about an inch, maybe an inch and a half, 2 inches at the most between my bit and the piece I'm drilling into. Because remember, that's affected by the throat difference, or the throat length. Okay? Now I'm going to set the depth. I'm going to remove my workpiece, and I'm going to loosen the depth collar, so that's all loose. And when I bring this down, I'm going to bring it down to where it touches the scrap. Now, I don't want to lock it at that point because the bit has a point and it wouldn't draw all the way through. So I'm going to back it up to about a quarter to maybe 3/8, half at the most. This will allow it to drill into the scrap piece but not into the metal table. So that's all. Our height and everything is set. Now it's time to secure the work. Which side of the table should I secure the work on? Or does it even matter? For safety reasons, I want to position the clamp on the handle side. Actually, the clamp can go anywhere. That works out. But the majority of the piece you want to be on the left. If you happen to hit a hard knot or some sort of part of the board that it causes the drill to lock up, the head's not going to stop turning. What's going to move is the piece. So by being it over on the left side, it's going to spin, it's going to hit the column. Now, I'm not standing in the best position, but this is for video purposes, so I'm going to, if I was standing right here with the board on the right and it locked up, it would come around and hit me in the rib. So again, board positioning is something you need to consider. Just to prevent from locking up, or if it did lock up, we want to secure the work. This is for safety and it's for accuracy. And you want to make sure you use a decent clamp. Sometimes the quick grips just aren't strong enough to keep it from moving. So I shake this, I kind of shake the whole drill. All right, everything's set. Body position again. I'm going to use 2 hands on the feed lever. I'm going to stand on the right side so I'm away from the column. And standing on the side on this one's is okay. I mean, you can position yourself in front, but I like this position right here because it allows you to use 2 hands. You're going to feed it all the way in, and you're going to unwind it. Don't just let go. That's hard on the throat. So go ahead and turn the switch on. Slowly feed it. You see how I'm using 2 hands? I'm drilling into oak, so I don't want to just ram it in there. I hit my depth stop, and now I'm going to unwind it. And as I kept it going as it came out of the hole. Shut it off, wait for it to come to a complete stop.
Want a lawn that looks like this, but your lawn looks a little bit more like this? Then you should click right here and check out TrueGreen. We're the local lawn experts that guarantee results you can see.